All right, I think we are ready to go.
It says live, so we must be going.
Yep, we're good.
Okay. So, did you do the preparation part?
Yeah, I did.
Did you understand it all?
Pretty much. As I read more, some of it didn't really make sense, like number 2 and number 3. Is yours echoing?
No.
Okay. Number 2 and number 3 were a little confusing.
Yeah, I wasn't sure what answer. Yeah. But
there we go.
After looking at the and checking with the answers, I kind of get it a little bit more.
Yeah. So yeah, same thing. As I read more and as I read like the answer key, because some of it, like 2 and 3, I was like, a bell shape? Like, I don't know what you're asking, but
that's what I did too.
Yeah.
Oh, normal. Okay.
Yeah. Yeah.
Oh, yeah. All right. Well, let's look at number 7, I guess, which is the first one for us.
Okay.
So did you look at this at all? Oh, that's the wrong one. I have the homework part up too. So did you look at this at all with the salaries and everything?
I've looked at it and I didn't print it out, but I was just going to write it on a piece of paper and cut it out really quick.
Well, it also says that, and this is what I did because I didn't print it out either. If you go to whatever link, random numbers, whatever, random.org/integers, I did that and it gave me 5 random numbers to choose from, and so we could do that instead of cutting it out.
Oh, I like that idea. Okay. I just opened that. All right. So if one of us wants to do that, because I'm sure we'll both get different numbers.
Oh, we will.
So
I have 5 random numbers.
Okay.
If you want to kind of write them down so you know what they are too, I guess we'll just use these ones.
Sounds good.
So the numbers that it gave me were number 26, 20, 17, 5, and 10.
All right.
I think that comment is in the wrong spot on that one. Yeah, probably. 10. Okay. So, asking for the mean. The mean, if I remember right, is just finding out the average, right?
Yeah.
So, plug these into the old calculator here. 49,800 plus 37,900, 39,600, 34,400, and 45,500. Divide that by 5. So I got a mean of 41,440.
Okay, 1 second. You got 41,440, right?
Yeah.
Okay. Okay. Right, so what is the mean of your sample? We got that.
Make a mark on the horizontal axis to indicate the value of your sample mean. To your right, down there. I mean, a little more than halfway between the 40,000 and 42,000, which is on the left end of this.
Yeah.
Does your sample mean appear to be unusual?
Yes, right? Because
it's not towards the population mean, right?
yeah, that's what I would assume.
So that's okay. I would say it appears unusual. And I would say it appears that way because a random sample of 5 out of, a combination of, the sample's not very big.
Because what is the, okay. So it says there's 142,506 possible combinations.
Yes.
So,
Well, we only came up, they'd asked us for one combination of 5 out of 142,000.
yeah, so the central limit theorem or whatever on number 5, it says that if the sample size is sufficiently large, then the sample mean will be pretty normal.
Yes.
So
It'll be
if the
close to the
sample
population mean.
size like we had was pretty small.
Yeah, that's what I was thinking. That it's unusual because our sample size is small.
Yeah.
Okay.
Alrighty. Says compare, are you ready for D?
Yeah.
Okay. Compare your mean from question 7A to the means obtained by at least 3 other individuals.
Well, maybe we should do this
3 other times.
So yeah, let's just go back on. Let's run it. I actually still have this one up. 1 to 30, get numbers. So we'll just, since there's only 2 of us, come on now, give me the dang numbers. There we go. All right. So I've got 20, 24, 13, 30, and 15. Let me do it again. Gives me 21, 22, 9, 30, and 18. And one more time for a third. Other 2, 17, 25, 21, and 12. All right, so I have 3 other sets of numbers.
Okay, I'll find the mean for the first one.
Okay.
Find the mean for the second one, and we'll just get it done quick.
Yeah, did you hear the numbers I gave for the first one?
24, 20, 13, 30, and 15, right?
Yep. Yeah.
Okay. What was the third set of numbers? And I'll do that one really quick.
2, 17, 25, 21, and 12.
Okay. All right. What was the mean for yours?
50,080.
All right.
And what
And
was the
for
one for your
the,
two?
huh?
No, I think you were going to tell me what the other two were.
Oh, yeah. So the first one was 45,640. And the third one was 46,960.
The third one was what? 46,960?
Yeah.
Okay. All right. So there's those three. That's interesting. Two of those are pretty close to the mean, it looks like.
Yeah, the 45 and the 46 are
Fairly close. The 50 is a little further out.
yeah.
What do you notice?
The other three I feel like were more normal compared to our first one.
Yeah. And you know, it's interesting because if you add all three of these together, so the sample sizes, or all four of them together, and the sample size, which makes the sample size larger, it's actually really close to the population mean.
Oh, really? Okay, that's really
Because
interesting.
the average of all those is 46,030.
Oh, yeah, that's.
But yeah, those ones, there are going to come times as they do this, even with a small sample size, that it could be close to the mean anyway.
So do we want to put that we noticed that several of them were more. I don't know. I had a question about this. Is the sample size is really small still? So would you still consider it normal, even though it's like just a chance that it happened to be right next to the mean, like of the whole thing?
I kind of think so, but also, well, no, because our sample size gets larger as we're figuring out different, because we're comparing them. So we're looking at the graph here that they have. And as we put all four on the graph, we kind of still get that bell shape, the normal shape, because we've got one on the left, two in the middle, and one on the right. So we still kind of get that same curve, you know?
Yeah.
So the more we get, though, obviously the closer it is to what, the greater the sample size, the closer we are to the population mean.
That's true.
And so as we're doing random, because we did it randomly, you got to what am I trying to say? As we do it randomly, it's going to create kind of, obviously, the greater the sample size, the closer it gets.
Yeah.
Whereas if you're just looking at a single one, I think it ends up being chance that it would be close to the mean.
Okay. I think that's, yeah, a good observation.
Did that start right after? There we go. Oops. Okay. So we good on that one then?
Mm-hmm.
All right. So number 8. The graduate management admissions test is used as an admission criterion in many Masters of Business Administration programs. The score on the GMAT are normally distributed with a mean of 529 and a standard deviation of 113. Consider a simple random sample for n equals 10 students taking the GMAT. What is the shape of the distribution of the sample means for all such samples? Well, it says it's normally distributed, so if I remember right from watching the video, if they're saying normally distributed, the shape would be normal, and probably a normal bell shape,
Yeah,
right?
that's what I would think, is that it would be pretty normal. So then the next one is, how do you know the distribution of the sample means has this shape? And it's just like what you just said.
Well, because they're normally distributed.
Yeah.
Because that was one of the two ways that it said it would be the normal shape, if I remember right. What is the mean of the sampling distribution of sample mean scores for all such samples? It's going to be the same as the mean, so 529.
Okay, sorry.
Oh, okay.
What is the mean of sampling distribution of sample mean scores for all such samples? So is it like what we just did when you take like several different ones, and the mean of all of those will be pretty close to the mean of the overall one as well, right?
No, the mean stays the same.
Yes.
So it would be 529 because the mean up here is 529.
Oh, that's right. Yeah.
So if I remember right, that should say the same. What is the standard deviation of the sampling distribution of the sample means for all such samples? Okay. We have, take the standard deviation, which is 113, divide that by the square root of the sample that we took out of there of 10 then, if I remember right. Divided by square root of 10.
Is it the square root of 10 though?
Is what, the square root of 10?
So the deviation, or standard deviation, is 113 divided by the square root of 10.
Yeah.
Okay.
What did I just... Which gives us 35.734, because I just rounded. $35.734
is what you got?
Yeah.
Okay, that's what I got as well.
So that's all of them. I guess we can check our answers now to see how we did. So I got that up. All right, so 8A didn't really, because the answers are going to be different for every group, there's no answer for 7 on here.
Yeah.
So 8A is normally distributed. So we put normal. How do you know the distribution of the samples? Because the parent population is normally distributed, which I believe is what we said. I guess I should have put parent population, not just sample. Okay. The mean of the sampling distribution is 529 and 35.734 for the standard deviation. Hey, look at that. We got those right.
All right.
Okay, so let's save that.
So do the group one now.
Where am I? Okay, we'll go to there. Okay, let's go back to this. Now we just do the homework quiz. No, that's homework group. I was doing the homework earlier. Here is group. Oh, this is where we post whatever. Right. Oh no, okay. So we have done that. I got activity complete. Group meeting. Here we go. Now we can start the quiz. You ready for this?
Yep.
All right.
Let's go.
I did do that. 1 and 2, I'm good so far.
Woo! We know those two are right.
Taking samples of n equals 5. What was the shape of the distribution of means histogram when the parent population is right skewed?
It was right skewed as well, right?
I believe so.
Or skewed right. Wait a second. Okay, yep, it is. So to think about that.
But when taking samples of 100, what was the shape of the distribution of means histogram in the parent population?
It's still more towards the left part of the graph, but it's more normal just on the right side of the graph, or the left side of the graph. Does that make sense?
So when the parent population is right skewed with the samples of 100, it's closer to, it's more normal.
I would think normal. Because I just did really quick like the 530 or whatever.
Uh-huh.
And it, instead of being like this on the, so instead of it being completely like this, it's just normal, but just on the left side of the graph to where there's nothing. Does that make sense?
Yeah, I'm trying to picture it because right now you're backwards to me. So,
Oh.
This is.
Yeah. Okay.
Yeah, I think so.
Okay.
So we're putting more normal.
Yeah, that's what I would.
Okay. Well, it's a larger size. The larger size means it's going to be closer to the parent, closer to the normal mean or whatever.
Okay, number 5.
Sampling distribution.
It was normal, right?
So was that this? So when using n equals 5, what was the shape of the distribution? Well, it should be normal because if the parent population is normal, it's gonna be
that's
normal,
what I would
right?
think.
I'm taking samples of 100.
Same thing, normal, because it's a bigger sample size, so it's closer to the. thing, which is normal to begin with.
That's what I would think also. Yeah, that's what I'm thinking too.
I do have a question really quick on number 4. So back to the skewed right diagram or whatever, histogram. With 100, would it be skewed right like the larger sample is?
Trying to think. Oh, I'm not sure.
I'm thinking that it is. I don't know. You're welcome to leave yours on normal if you want. I'm thinking it is because it makes it so the larger the sample size makes it closer to what the overall sample size was, right? And the overall sample size was skewed right.
It's skewed right because that's the parent population. So then is number 3 wrong because it's a smaller sample size?
So number 3, I would guess, would be normal. I don't know.
Because I think you're right. Because if I remember right, it says that the larger sample size brings the mean closer to the parent population. Right?
Yes.
So if that's the case, then number 4, it's a larger sample size. It should be closer to the parent population, which is right skewed. So it should give a right skewed shape in theory.
Okay.
I think.
And number 3 would be just.
It could be normal. I can't, when using what the heck was, when taking samples of n equals, when.
I'm wondering if it would still be skewed right.
Well, hold on.
Just because the fact that it has, with only 5, it has more of a chance to be skewed right than it does in the normal.
When using, what was the shape of the distribution mean? Parent population is right skewed. What is the shape? I think it's more normal.
Okay.
I think. I could be wrong. I don't like being wrong. I put normal.
Okay. Sounds good.
Number 7.
Number 7.
When would the distribution of means be normally distributed? Well, data are drawn from a population that is normally distributed. If it's normally distributed, small size or large, it's going to be normally distributed, right?
I believe so. So the top 3 then?
Shoot. See, this kind of ties into 3 and 4 and what we put for it.
Yeah. So we know for a fact the bottom one won't be normal because it's right skewed in a large sample. And we know for a fact the top two would be normal, right?
Because they're normally distributed already, which means it's going to be possibly the top three. Not 100% sure on that one. But that's what I'm putting. All right. We ready to go on to number 8?
Yes. And we just did the top three, right?
Yeah.
Okay.
Which of the following gives the best explanation of the central limit theorem? If the parent population from which the data are drawn is normally distributed, then the sample mean will follow normal distribution. I think it's that one. What do you think?
Okay, let me read them all. I agree. I think that's the one. And it's not 2 because that's a 68, 95, 9.
And it's not 3 because and 3 describe the large number, whatever it's called. And actually, I think it's more C or D describes a large number.
That's, yeah. So if the sample size is large, then the sample distribution will be approximately normal.
Okay, so I think it's A.
A?
Yeah, that's what I think.
Okay.
Number 9.
Let X be a random variable with the population mean 10. Standard deviation 6. Suppose the sample size is 36 is drawn from this population. What is the mean of the distribution of the sample means? It would still be 10, right?
Yeah.
Because that stays pretty much the same. And then 10 is just what is the standard deviation of the distribution of the sample of means?
So we take the standard deviation divided by the square root of the sample size, which gives us 1.
So yeah, just 1, right?
Yeah, they want 3 decimal places, so 1.000. Unless we're completely doing it wrong.
No, I think we both got the same thing, so hopefully that's right.
All right, number 11. Regardless of the distribution of the population, if the sample size is large, what would be the shape of the distribution of the sample mean?
So 30 it was talking about is like the magic number, kind of, that's large.
Yeah.
So it would be normal, right?
Okay. But if that's the case, we're talking about up top with 3, whatever, the ones, they're talking about sample sizes of 100, and we're following the parent population. Whereas should it be normal then? Like 3, 4, and 7, you know what I'm saying?
Yes, I know exactly what you're saying. Okay, but number 12 says the theorem that would justify your response to question 11 is law of large numbers, right?
Yeah. Yeah.
So if we go back up,
So then would 4 be normal and not right skewed because it's a large sample size?
so would 3 be right skewed and 4 be normal?
I think so. And I hope so, because that's really what I'm feeling right now.
Sounds good.
Which means 7 then. When would the distribution of means be normally distributed? It's got to be a sample size is large. So it's got to be A, B, and D.
Okay. Yeah.
Oh, now I'm questioning myself. Okay. Are we as comfortable as we're going to be with these answers?
I think so. Yep.
All right. I'm about to hit submit.
All right. I am too.
Oh, my eyes are covered. What did we get wrong?
Well, we got the normal and the, yeah.
Yeah, we switched those and we got number 8 and, oh, what? I'm so confused right now. Regardless of the distribution of population, if the sample size is large, why is that the central limit theorem?
And then that means 12 is wrong too.
Yeah. It was, okay, so central limit theory is if the sample size is large, the shape of the sampling will be approximately normal. Oh, I think we just got those two mixed up.
I think so too.
And B is not bad. All right, done.
All right. Sounds good.
Close this.
Then I will post this on the group.
Awesome.
So
my goal on Thursday is to be online before I go into the Disneyland park.
Okay. Yeah. What time do you need to meet earlier?
No, that'll be fine. They're an hour ahead, so it'll be 8 o'clock while I'm there. So that's fine. I don't know that I'll be up before that much.
Okay. That's just fine. Okay, sounds good. I will have everything done, and yeah.
We'll be ready for it
next week. Okay, Sweet. Sounds good. Have fun in Disneyland.
Thanks.
Bye.